All right, guys, we're going to do a quick overview of activity 4.2 part 1. All right, so today's kind of task, right, to read the LEQ. So if you can't see it, how do you know it's there? So we're going to be studying parts of the atom that we really can't see. The reading in this particular activity is extremely important. All right, the reading kind of talks about indirect versus direct evidence. Indirect evidence, like it says, when collecting indirect evidence, measurements or observations are made of one thing to get information about another, right? So again, indirectly gathering information by studying something else, right, is how we're going to go about studying atoms. Direct evidence is literally, if you take a rock, put it on a scale, you can observe the color of the object, you can see it, touch it, use your senses, use tools to measure it. That's direct evidence, okay? It talks about examples. We study dinosaurs indirectly. We've never seen an actual dinosaur, right? So we have to study their bones. We have to study kind of their dung to kind of get an idea of what dinosaurs look like so we can kind of have an understanding, okay? Even studying the sun. No one has been to the sun. No one can get near the sun. It's too hot. But we can study and compare the light from the sun to things that make light on Earth to kind of compare and see what the sun is made out of. We study the sun indirectly. So again, the moon and stars, and Mars. We study Mars based off of indirect evidence, kind of alluding to ideas about Mars based on things that we found there. So finally, we know we're going to have to be studying atoms indirectly, all right, as we move forward. We're not going to be able to see an atom. We can't visually see an atom. We can't touch an atom, but we're going to study it based on different ways, okay? So as we scroll down, I asked you guys to do some questions. So a quick slideshow of cathode rays. So this is a cathode ray machine. The first hint, this experiment gave us the first hint that atoms might be made of even smaller particles. And that's the idea here. We're trying to figure out what atoms are made of, what particles make up atoms. So the first hint that atoms might have been made of even smaller particles came from an experiment done by J.J. Thomson in 1897, in which he was studying newly discovered cathode rays. Here's a cathode ray machine. It creates cathodes or electrodes, and he shoots it through a beam called a cathode ray. All right, so here's a picture of what we're looking at. And you're going to see this also, if you watch the video about this is also how our first types of TVs were used and how we watch TV and old computer screens or use this. And that's all in the video. So it's a great video to watch. I wouldn't skip over this, all right? So as we look at this first kind of simulation, so again, we're focused on J.J. Thomson, the first scientist to kind of revise the model of the atom. This simulation is an animation of an experiment that J.J. Thomson conducted, which provided the first glimpse into the structure of the atom and led to one of the most important discoveries in history. What you're going to do is use this simulation to collect data and to see if you can come up with some conclusions about cathode rays that Thomson did. So work with the simulation where the two electrodes are connected to a high voltage source to see when them produce cathode rays. J.J. Thomson used a similar experiment set up to discover the first subatomic particle. So what we're going to do is turn this bad boy on, all right? And we can see that the beam starts to bend. It bends towards this positive charge plate and away from the negative charge plate. So if I turn it on very high, this happens. If I change, right, and I make it, the plate's different, right? So you can see the stronger the charge, the greater it bends. The weaker, obviously, and this goes back to investigation 2 about factors that affect charge. So we know no matter what, this beam always, and I've turned it to particles, these particles always move in what direction? They always move toward the positive. And if they always move toward the positive, what does that tell us about the charge of the particles? All right? Let's go back to beam. If the beam always moves toward the positive and it tracks towards positive, what does that tell us about the charge of the beam? We also have the ability to change the type of material we're making. So if I change it to gold and the iron, we see there's no difference. It doesn't matter what element it is. We see the same type of results. So that tells us no matter what, the atoms have this similar particle, no matter what you change it to. So it's important to note as you answer these questions for the cathode ray simulation, all right? So that's very important to look at and utilize, understanding this simulation, that this beam is charged. What is the charge based on the direction it bends, right? And does changing the material have any effect.